In this lesson, we'll look at the use of coded factor in calculating the arithmetic mean. To start with, what is a coded factor? A coded factor is obtained by dividing the deviation by the class width. Recall from our previous example where we learned how to find deviation when assuming is given. The deviation is usually each of the items within the data minus the assumed mean. So if I'm making use of a coded factor, the coded factor, which is usually denoted U, is this deviation D divided by the class width. And what is a class width? When data is grouped like this, the number of items within a particular group is called the class width. So like this 40 to 49, how many items do I have there? 40 is number 1, 42, 43, 44, 45, 46, down to 49. If you count, you will have 10 items there. So that number of items within a class interval is what we call the class width. 50 to 59, there are 10 items there. 60 to 69, there are 10 items there. You can count by yourself. Count starting from 40, then count down to 49. Most students used to make mistake of saying it's 9 by subtracting this and this. No, it's not subtraction. You count the number of items. If you are not sure, you can write it down: 40, 41, 42, 43, 44, 45, 46, 47, 48, and 49. Less than 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So the class width here is 10. So to make use of coded factor in calculating the arithmetic mean, we need to prepare a table that will show us all the things that we need to work with. The questions in the table below shows the distribution of the masses of a number of inmates in a zoological garden. Using an assumed mean of 84.5, calculate the mean mass of the distribution. So what are the things that need to appear in our table? We need to first of all get the masses, which is already given to us. So because the table is wide, let me start from here. Masses kilogram. And the next thing we need to get is a class mark. Remember, when data is given in interval like this, the value of S is the class mark of each of the class interval. And the class mark is obtained by adding the lower class limit to the upper class limit, then divide the result by 2. So we need to get class mark here. Class mark, which is now the X, each of the data. I also need to get the frequency, which is already in the table, frequency F. And we need to get deviation from the assumed mean, which is each of the X here minus the assumed mean. And we also need to get the coded factor U, which is the deviation from the assumed mean divided by the class width of the data. We also need to get the frequency multiplied by the deviation, by this multiplied by whatever we have here. And finally, we also need to get the frequency multiplied by the coded factor. So when we get all of these, before we can calculate the arithmetic mean, making use of the coded factor. So let's impute the data one after the other. The first thing I have there is 40 to 49, 40 to 49, then 50 to 59, 60 to 69, 70 to 79, 80 to 89, 90 to 99, then 100 to 109. So for the class mark rather, we get the class mark by adding the lower class limit to the upper class limit, then divide the result by 2. 40 plus 49 is 89. 89 divided by 2 is 44.5. 50 plus 59 is 109 divided by 2 is 54.5. Then 60 plus 69, that is 129 divided by 2 is 64.5. If you look at this number, if there's a difference of 10, of course our class width is 10 that we have explained earlier. So to get the next class mark, just keep adding 10 to the preceding one instead of wasting your time doing calculation. 10 plus this will give us 74.5. 10 plus this will give us 84.5. 10 plus this will give us 94.5. And then 104.5. The frequency is the number of inmates for each of the class interval. So the first one here is 7. The second one is 5. The third is 10. And we have 18 for the fourth one. And we have 8. We have 12. And then finally 10. Okay, I'll get the deviation from each of these x. Remember that deviation is x minus assumed mean. The assumed mean according to the question is 84.5. We're using an assumed mean of 84.5, calculate the mean mass of the distribution. So D, which is x minus assumed mean, x is this class marks now, 44 minus 84.5, that is minus 40, minus 40. 54.5 minus 84.5 is minus 30. Can confirm it by using your own calculator. Then 64.5 minus 84.5 is minus 20. And we have the next one is 74.5 minus 84.5 minus 10. 84.5 minus 84.5 is 0. 94.5 minus 84.5 is 10. And finally, 104.5 minus 84.5 is 20. Then coded factor U is deviation divided by class width. So we're going to divide each of these deviation by the class width. Remember that our class width is 10, which we get by counting the number of items in each of these intervals. If you count from 40 to 49, you have 10 items there. So minus 40 divided by 10 is minus 4. Minus 30 divided by 10 is minus 3. Minus 20 divided by 10 is minus 2. This will be minus 1. 0, 1, and 2. And FD is, where is D? D is here. That's 40 times, 7 times negative 40 rather. It is negative 280. And 5 times negative 30 is negative 150. 10 times negative 20 is negative 200. 18 times negative 10 is negative 180. And 8 times 0 is 0. 12 times 10 is 120. 10 times 20 is 200. That is FD. Then finally FU. F times is 7 times negative 4 is negative 228. 5 times negative 3 is negative 15. 10 times negative 2 is negative 20. Then 18 times negative 1 is negative 18. 8 times 0 is 0. 12 times 1 is 12. And 10 times 2 is 20. Okay. The next thing we need to do is to get the summation FD. We need to add up this summation FD. When we add up all of this, we have negative 490. Negative 490. I also need to get summation FU. When we add all of this values here, we have negative 49. So with all of this now, we can calculate the arithmetic mean. Remember that the assumed mean, let me call it AM, according to the question is 84.5, 84.5. Then we have summation F. That is, if we add up all this frequency, we need to do that also. Summation F is 70. I think it's given in the question too. Is it given? No, it's not given. So when we add up all this frequency, we have 70. Then the next thing we need to do now is the use of the calculation of the assumed mean. So summation F rather is 70. Summation FD minus 490. Then summation FU is minus 49. The mean X bar is assumed mean, and we call it NAM, plus summation FD over summation F, which is 84.5 plus minus 490 over 70. And that gives us 84.5 minus 7, which is 77.5 kilograms. Another way we can solve this is to use the class width rather, and the coded factor. So assume mean plus summation FU over summation F times the coded factor. So what we are doing in essence, we first of all use the assume mean only, and want to use the coded factor now to see whether we'll get the same answer. So this is an alternative method. Alternatively, now what is our assume mean? 84.5 plus summation FU is negative 490, negative 49 rather, over 70 times the class width, which is 10. If I open up this bracket, of course, this 10 will multiply this, which is T 84.5 plus negative 49 times 10 is negative 490 divided by 7. Looking at it, it's still the same thing we have here. 84.5 plus negative 490 over 70, which will still give us the same answer, 77.5 kg. So that is how to make use of the coded factor in calculation of arithmetic mean.